So we just looked at how to find the domain and range from ordered pairs and also from a graph. Now, when we look at an equation, all we want to do in this course is look at just finding the domain. So we can leave range for another class, but what we do want to do is find the domain. So remember we said the domain was the list of all possible x values. Now that could be a whole lot of numbers, and we saw that in a graph, some of them were like infinitely many. All right, so sometimes it's easier to explain a domain by saying what values it cannot have versus what values that it can, because there's just too many possibilities that can happen and only maybe one or two places that cannot happen. So that's kind of what we want to look at. Find where the values can or cannot be, depending on what the equation is. Now, in this class, we'll actually look at 5 possibilities, but the 5th one comes in chapter 4, so that one's long. We're waiting on that one for a little bit. So what we want to look at right now, we're going to look at 4 possibilities. And it actually comes from 2 kind of equations that we've already looked at before. We've looked at fraction or rational equations, and we've looked at the square root or radical equations. Those are the 2 that we want to look at. Now, when we put those 2 together, we end up with 4 scenarios. So we could have just a regular fraction. We could have a square root. We could have a square root in the numerator, and we can have a square root in the denominator. Okay, so that kind of is where we get those 4 cases. And each of those cases, while they're going to look very similar when we're solving them, they'll end up actually having a little bit different answer when we come to the end. Okay, so the first one we're going to look at is looking at what happens when we have just a fraction. So if we think back to when we were solving those rational equations in chapter, I think 1.2, what we were looking at was being able to check in the end against that common denominator to see if there was a restriction. The reason that we were doing that was because we know that we cannot divide by 0. So that's what we're looking at here. We want to know in a fraction, we know that we cannot divide by 0. So that is going to be what we're going to need to look at. So what that means for solving is that I'm going to set the denominator equal to 0 and solve it, okay? So let's look at this first example. Since this is a fraction, I'm going to take the denominator and say, well, the denominator cannot be 0. So we set it not equal to 0. When I go to solve this, I solve it exactly like it is 0. So having the line in the middle saying that it can't be that does nothing for the solving part. Okay, so I'm going to quickly solve this. I would subtract that 4 to the other side. So I say that x cannot be negative 4. So that's one way to state what the domain is. So the domain is going to be all numbers, all real numbers, except x equaling to 4. So I could write it like that. I could just say x cannot be, negative 4. Or I could write it as an interval. So when we write this as an interval, if we think about, well, what number can it be? Well, it can be everything except for negative 4. So think about a number line here. If I were to shade on this number line, I would be able to shade everything to the left of negative 4, everything to the right of negative 4, except negative 4. So I would have an open dot right there at negative 4. So the way I would write this is that it could go from negative infinity to negative 4. Then it's going to have to jump over negative 4. We use a union. It's going to pick back up from negative 4 and go all the way to infinity. Okay, remember a union means I'm taking 2 pieces and putting them together, like I took these 2 shaded pieces. And the parentheses, because remember we actually cannot be negative 4. All right, so that's how it would look if we were writing it as an interval. Okay. So fraction, since I cannot divide by 0, what I'm going to do is I'm going to set it not equal to 0 and solve. Right? The next scenario that we have is a square root. So let's think about a square root. Remember when we were looking at complex numbers, we said, well, a complex number became imaginary when we had a negative under the radical. So in a square root, this time we can't have a negative under the radical. So instead of last time we were saying, well, it's not equal to 0, this time we're going to say it must be greater than or equal to 0. I can have the square root of 0, it's 0, but I can't have the square root of a negative number. So this time we're going to say it can be greater than or equal to 0. So what we're going to do is we're going to take what's underneath, so that 5x plus 20, if we're looking at this first example, and we're going to say it must be greater than or equal to 0. So notice on both of these I'm using the number 0, but I'm using a different inequality. Okay, so I'm going to solve this again, nice and easy solving here. I'm going to subtract my 20. Then I'm going to divide by 5. Since I did not divide by a negative, I leave that sign alone. All right, so now I say that I can have all numbers greater than or equal to -4. So I could write that as my domain. I could also write that as an inequality, as an interval. That was the inequality. So as an interval, think about how I would write this. If I'm going to be greater than or equal to 0, let's put it on a number line just so we make sure we can visualize it here. If I'm at -4, I want to be greater than or equal to. So I'm going to be shading to the right. I can be equal, so I'm going to use a closed dot there. So when I go to write that as an interval, I'm going to start at -4 using a bracket this time. And then I'm going to go off to positive infinity. Bracket because I had the closed dot, positive infinity because we went off to the right there. Okay? So those are the two main ones that we're going to look at. And then I want to say, well, what happens when I put those two together? So I could have the square root in the denominator and the square root in the numerator. So let's look at the square root. Let's see, I've got listed square root in the denominator. So if I have a square root in that denominator, and it's actually this fourth example. Sorry, that was my bad. So it's actually going to be this fourth example here. If I have that happen, what I notice is that both of these two things are occurring at the same time. Remember when we had a fraction, the denominator was the issue. And that's exactly where our radical is. So what we're going to do here is we're going to say, well, it can't be 0. Or negative. So what that means that we're going to do is we're going to take that 4x plus 12, and now we're going to say, okay, not only can it not be 0, not only can it be greater than or equal to 0, but 4x plus 12 must be just greater than 0. So we're going to put those two pieces together. Okay. So the solving's super easy again. I'll move the 12. I'll divide by 4. So I see that the domain is that x is greater than -3. If I wanted to write that as an interval, if I'm greater than -3, I'd start at -3, just like we did on the last one, going to infinity, except this time I would have a parenthesis because there's no equals. So if I notice so far, they've been very similar. I'm using a 0 every time, except for sometimes there's a bracket, sometimes there's a parenthesis, sometimes I have two sets of infinities. So in the end, it looks quite different, but I'm all starting from 0. All right, so let's look at this very last one here. This last scenario is when I have the square root in the numerator. So now what I notice is that I've got my two things, fraction and square root, in two different places. So Now I'm going to say, well, I can't be negative in the numerator. And that's important when I use the word and I can't be 0 in the denominator. So I notice that these happen in two different places. What that means is I'm going to have to solve two different problems. I'm going to have to solve one and I'm going to have to solve another one. So it's not any more difficult. It's just, I guess, twice the work. So the first one I'm going to do is I'm going to say 2x plus 8. That's my numerator, so that one cannot be negative. So I'm going to say is greater than or equal to 0. That's my first one here. And my second one, I'm going to take the denominator, x minus 5, and say, well, that cannot be 0. So let's solve these real quickly. I'm going to subtract 8. 2x greater than or equal to negative 8, divide by 2, x greater than or equal to negative 4. And then I'm going to solve my second one. I'm going to add the 5. X cannot be 5. So both of these things is going to be my answer. So x must be greater than or equal to negative 4, and then it also cannot be 5. So my domain has to include both of those. So let's see what that would look like if I were to put that on a number line. So I'm going to start here at negative 4 and then put a 5 there. So let's just kind of graph this out. I'm going to be greater than or equal to negative 4. So I'm going to take negative 4, put a closed dot on that, and I'm going to go all the way until 5, but then it says I can't be 5. So I'm going to need to put an open dot on 5, and then I keep going. Right, so how would that look like if I wrote it out? Well, I'm going to start at negative 4. I'm going to use a bracket on that. Then I'm going to go all the way until 5, so I got to stop at 5. Remember on our first one, when we had that hole, we were going to jump over it. So I'm going to put a parenthesis, I'm going to put a union to jump over the 5, and then go off to infinity. Right? So those two scenarios, those two elements, a fraction and a square root, actually create 4 scenarios, all of them involving 0, but very technical about, am I greater than or equal to, am I not equal to, am I just greater than, and being able to write it as an interval as well.